Hello and welcome to Computer Science 30S. This is SNAP or BYOB Lesson 8, Searching for a List. So after this lesson, you're going to know what the terms element and a parallel list are. You'll be able to understand the basic use for parallel lists, and you'll be able to search a list for an element and report its spot on the list. All right, so we've been dealing with lists, and as the list gets bigger, you may need to search in a list for a particular item. Each item is referred to as an element in standard computer science terms. That's the generic term for an item in a list or an array is an element. Both Scratch and BYOB and all its variations have a built-in searching command that looks kind of like this. Ask name to search for and wait. Set name search to answer. If names, that's the list, contains name search, then say it. And all this really does, this script finds out what name you're looking for and basically confirms that it's in the list. So it doesn't really do a whole lot other than say, yes, that is in the list. It might work for like a dictionary type of thing or something like that, but it's not really very useful because it just confirms that it's in the list, that kind of thing. So we're going to investigate this a little bit further. So let's rewrite this so that it tells us what spot it is in the list. So we're going to have to rewrite the script here. So go ahead and take a few moments, pause the video here, create this script, create this list as shown here, the standard one we've been using, Adam, Bob, Carol, Doug, and Ernie. I'll pause right here. You should do the same. Create this script, and then we'll have a look at it. All right, let's have a closer look at this particular one here. I'm just going to zoom in a bit so you can see a little bit better. Okay, so when the green flag is clicked, we're going to set the index to 1. We're going to ask the question, what name are you searching for? And we're going to set the variable name search to that answer. And then we're going to set up a repeat loop here. We're going to repeat all of this until either the item index of names is equal to the name search. In other words, we've actually found the name, or the index has exceeded the length of the names and we've otherwise reached the end of the list. So we're going to keep looking for the name until we either find it or until we run out of names. That's basically what we're doing. And we're going to say item index of names for 1 second. So we're just going to flash on the screen Adam. And then we're going to change index by 1. So we're simply going to keep going through each one at a time, each element in the list until I either find it or I run out. Now the problem with a loop like this where you've got 2 conditions that will end it is you have to have both those conditions checked once you do actually end it. So again here, we've got an if. So if item index of names is equal to name search, in other words, if I found the name, if I found the name, then you're going to say, hey, I found that name in spot index. So we're going to report the index as the array position, the list position that we found it in, or we're going to say not found. So hopefully that worked for you. If not, you might need to do a little bit of debugging, pause the video as needed. Now suppose we have 2 lists that exist in parallel. An example might be a list of names with corresponding high scores, or phone numbers, or ages, or addresses, or what have you, any kind of databases, this type of idea. So for example here's our standard list of Adam, Bob, Carol, Doug, and Ernie, and they have the corresponding high scores. So in other words, Carol's high score is 9,500, and so on. Suppose that item 3 of the names is Carol, and item 3 of that high score is hers as well. In other words, Carol has a high score of 9,500, as I was just saying. Okay, so there's a relationship here. In other words, the indexes match. The third element in each list have a relationship. They belong to the same thing, and if it was phone numbers or addresses or what have you, it would be exactly the same kind of thing. This is kind of powerful. So I'd like you to create a second list as shown with those high scores in it, and then modify the script like this. So instead of saying that I found it, okay, after the loop here, we're going to say that if items of indexes of names is equal to name search, in other words, I did find it, then I want you to say the name, and I want you to say what their high score was. So report the spot and include the value in the second list. So give that a whirl, pause the video as needed. Now, suppose someone came along and beat Carol's high score. How would we add a high score in the middle? And you should investigate the insert something at something of high scores command. You'd have to remember to, if you're going to insert it, you'd have to remember to insert the new name in spot number 3, bump everything down, and you'd have to make sure that you insert the new high score and bump everything down here. I believe Scratch, when you use this command, the insert, it actually does all the bumping down for you. Other languages like Liberty Basic, you're going to have to figure out how to bump, as I like to say, and move scores down, move names down, that kind of thing. Okay, so your assignment for this particular lesson is to modify your rock, scissors, paper game to include the following. The game should begin by asking for a player's name and searches to see if they've played before. So use a separate list of people who've played before. By the way, if your rock, scissors, paper game isn't a play against the computer game, you need to make that change as well. You should have another list that also includes their best score, most number of wins. In other words, for example, Dave has won 27 hands in one sitting. Note that the game no longer ends when the player gets to 5. They can play as long as they want, kind of thing. So you should have 2 lists, one with players' names that have played before, looks like this, and another list of most hands won. Okay, and it should be in order, just like that. Once a player chooses to end the game, the program checks to see what their best score is, replaces it if necessary. Of course, comments and proper naming of variables is a must, and the game should also prompt the player to save the program so that the list values are saved as well. Alternatively, right-click on the list. If you're a little bit ahead and you want to have a challenge, investigate how the import and export options work, and you can include that if you like. And you should hand this in out of 20 marks. All right, good luck with that. And this will conclude the end of the the Scratch programming, and we're going to move right into the project right away.